All right, last question, number 3. Since we're working with a lot of new graphs here, I'm going to reset my calculator once again. So I'm going to second plus 712 and clear it, press enter. All right, so use your graphing calculator to sketch a graph of the following exponential functions below. So we're going to start with a, which is y equals 4 to the x. So go ahead and plug this into your calculator. Y equals 4 to the x. And that's, so you can either graph it and take a look at the graph that's being made here, or if you want the exact points, let's go to table and we can get the table points there. I'm going to go back a little bit so we can get some negative points. So let's just start at -1. It's at a quarter. At 0, we are going to be at 1. At 1, we're all the way up to 4. And at 5, we're going to be way off the graph at that point. So I can see that my graph is going to do this right here, and it's going to get really big really fast. And that does, if I hit graph, that does seem to match that graph pretty well. So my asymptote, where is that going to be? Let's draw it. You can see that it's going to be at y equals 0 once again. So it's never actually going to touch that. And my y-intercept is going to be 1. It crosses right there at 1. All right, go ahead and try B on your own. Go ahead and pause the video. All right, if your graph looks like this, meaning that you have a point here that is -1, 4, 0, 1, and 1, 0.25, looks kind of like that. Asymptote is once again y equals 0. It's never actually going to cross that line. And my y-intercept is 1. All right, perfect. So if it looks like that, nice job. Go ahead and do C on your own. All right, perfect. Hopefully you were able to do question C. I'm not going to do it on the video, but I will be checking for it when I check your classwork on Friday. So let's go down to question D. Exponential graphs have a great deal of similarity to each other. List the similarity and differences of the 5 exponential graphs you have examined so far. All right, so I got, for similarities, I got 4 major similarities and 2 differences. So go ahead and pause the video, see if you can come up with these on your own first, and then when you have brainstormed a little bit, or maybe gotten even a couple of them done, go ahead and resume the video, and then we can go over all of them. I'm sure there's more than what I came up with, but let's see what you can come up with first on your own. All right, so some similarities that I got is, first of all, we're working with a curved line. So this exponential line is completely new from anything that we've talked about before. It's not linear, it's not a perfectly straight line, and it's not a parabola that we saw in quadratics. So this is a new curved line that we have. My asymptote is always going to be y equals 0. So there's always going to be a horizontal asymptote on the x-axis. Another similarity that we always saw is that their y-intercept is always at 1. So there's always a 0, 1 point. And then last but not least, it never goes below 0. So there's no negative y values. They just don't exist with exponentials. All right, a couple of differences I saw is that sometimes it's decreasing, sometimes it's increasing. And the biggest difference is that that rate of increase or the rate of decrease is always different. And we know what the rate is based on our growth ratio. And we know that's what's inside the parentheses. From our previous knowledge of exponential equations. All right, after you're done with this, go ahead and take out your homework and get started if there's still time left in class.